If you remember last lesson when we started this topic, there were seven words that we learnt when it came to geometry and proving what angle something is. Yeah, so that was sort of the learning intention and the success criteria, which was also tied in with using algebra. Yeah, we started looking at algebra in order to prove something being the angle that it is. All right, so complementary angles, remember, are angles that add up to 90. So whenever you're working with an angle of some sort, and you got to prove that it's something, if it adds up to 90, we have to say that it's complementary. Okay, we have to use evidence essentially to prove this. Supplementary is angles adding up to 180. Revolutionary or revolution is 360 because it's like a turn, full turn. And then vertically opposite is if you've got two lines that look something like this, the angles opposite them. Okay, so if you're looking at, for example, this angle, that angle here are actually the same. Okay, A and B are also the same. Oops. Okay, they're exactly the same angles. Okay, so just think of vertically opposite as same angle on the opposite side. That's all it's saying. And we did some of these questions here. Yeah. And the other things we learned as well. So the other four were alternate angles. So when you have a parallel line, so these two lines being parallel, remember, I think Tommy had a good definition for parallel lines. It's lines that never meet, or it's like a railway track. The tracks never meet or cross one another because they're parallel. They're straight. Okay, they're both straight with one another. Sounds weird. Anyway, so when we're looking at alternate angles, normally with parallel lines, what you'll do is you'll have a line that goes through both of the lines. And then you're looking at what angles are the same in those, in the diagram. So if you look at A here, that is the same as B angle there. So you call that an alternate angle. Okay, it's the same angle but on opposite sides. Maybe that's one way you can think of it. Same angle, opposite sides. Corresponding. Okay, so if you have your parallel lines, you've drawn the line through it. A corresponding angle is the same angle on the same side. So A and B, okay, are the same angles there. When I'm talking about the sides, this is the side I'm talking about. So if you got your transversal, this is one side, and that's the other side. You're just literally splitting it in half. Okay, so for corresponding, it's the same angle on the same side. And then for co-interior, their angles, and the reason why it's co-interior, okay, is because it's inside. You can see interior. Okay, inside of that side here. So if you're looking at this shape, it's the inside there. They always equal. Shh, Attila. I know you're talking about the work, but that's great. But just listen here. You're talking about here an angles that equals 180. And the reason why is if you look here, this angle plus this angle should equal 180. And if you look that angle there and this angle are actually the same as well. So when you add them together, it should equal 180 degrees. Okay, and that's co-interior. They always equal 180. All right, and we did some examples there. Let's actually look through some of these examples here for now. Triangles, which is where most of you guys got a little bit confused. Yeah, so when you look at a triangle, any triangle, you look at all the angles in a triangle, it always equals 180. So triangles, angle A, angle B, angle C, and when you add them all together, it's always 180, always. Okay, and I don't know if this makes sense to you, but the reason being is if you get a triangle, right, and you cut off all of its corners and you put them together, okay, so if you cut off this, you cut off that, and you cut off that, it actually creates a 180 degree shape here. I don't know if anyone's seen that before. So if you get a triangle, you cut off the corners, you put them all together, it makes like a semicircle shape, okay, which is pretty cool. And that's what that's saying there. Here, that's why if you add all of the angles together, it always equals 180. And remember, a 180 is always just a flat shape or a flat line. That there is 180. And plus the outside, yes, if you add all that up, it's 360. Thank you, Colin. And remember, what's for 360 angles? It starts with R, revolution, yeah? This is a tech, but we'll do it anyway so you guys can get the understanding of it. All right, so for first I'm trying to figure out what is x, and I need to give it proof. So this triangle we know will always equal 180, which is fine, but we're missing one side. Okay, we're missing this side here. Remember, any supplementary angle will equal 180. So if I just put a question mark here, question mark plus 152 equals 180. So now I need to solve that.
180 minus 180.
Very good. Very good, guys. Smarter than me. After this. Okay, equals 28 degrees. So therefore, if this question mark is 28, let's put that 28 there. Remember, what did we say about triangles? Any triangle, you add them all together, always equals 180. So algebraically, remember, and this is where everyone freaks out because you don't like algebra, but all you're doing is you're just going to go x plus 80 plus 28 equals 180. Okay, that's all it is, and you just got to solve it from there.
72.
Let's not go ahead though. I'm going to do the full working out so everybody's on the same page. What I like to do when it comes to algebra is I like to put the numbers together first. So now it becomes x, well actually we'll go x plus, what's 80 plus, yep, thank you. There you go. Just make it easy for yourself, but if you want to skip this step, you don't have to do it. Okay, what's the next step, guys?
Minus 108.
Beautiful. Minus that 108. So this is a plus 108. So here it becomes minus 108. And therefore x. So what's 180 take away 108? It is 72 degrees. And okay, we know that triangles all equal 180. So you literally just write triangle. Okay, because all triangles must equal 180. You have to have that reasoning. What I've realized in year 11 is if you don't write this down, and in year 12, they won't give you the full mark, unfortunately. You got to write it. Even though it's weird, they want reasoning. They want to know that you know that it's a triangle. Weird, I know, it's weird, but that's what they want. And let's just do what they say, hey, so you can get full marks. Always. Because I told you. Oh, okay. Actually, I'll explain again, Mr. Cohen. So if you triangle, yeah, and you cut out all of its corners, and then you stick them back together, it actually makes a 180 degree. That's why. Any triangle. Okay, let's move on. Let's move on. I might just do let's just do A, which is this one down here, and then we'll do the next bit. All right. What do you notice that's interesting with this triangle, guys? It's missing a bottom. Good. Yes.
It looks like there's two.
It looks like there's two. Good. Yes. Because there's parallel lines going on here, which is cool. What do you think these are?
The same.
It means they're the same. Does anyone know a triangle with two of the same sides? What do we call that? No, that's all three. That's an isosceles. So whenever you have a triangle that's isosceles, okay, that means two sides are the same, but also because two sides are the same, two angles have to be the same. Okay, that's when it comes to an isosceles triangle. Now here's the cool thing with this triangle, yeah? You can see there's parallel lines here. Cool. What do you notice about this angle? It's 38. Does it have an alternate in there somewhere? Have a think.
Yes.
Where is it? Right here.
Yeah.
That has to be 38 too, okay? It's an alternate. Okay, 38 degrees. I skip B, yeah. I'm doing A, well, according to this. So, if that's 38, okay, and I've got two angles here that I don't know that must be the same. I don't know what they are though. But, remember, okay, that because this is isosceles, this angle also has to be X. I don't know what it is, but it's X. Okay, it's X. They have to be the same. So how do I work out what that is then? Yes, Alana.
180 minus 38.
Yeah, but what about the X's? You don't know what the X's are?
Divided by 2.
Good. Okay, so this is what you could do.
Mr. You skipped B.
I did skip B, yes. I did that on purpose. We're doing A. Okay.
I don't get it.
This question here,
Yeah.
how do I get 38, you mean? It's 38 because over here,
Oh, the lines, two lines.
exactly, they're parallel, so that has to be 38 too.
They just caught up.
Good. All right, so just going back to what Alana said, algebraically you would write 180, actually, let me do it properly.
180 minus 38 minus 38.
Well, no, you'd go like this, 38 plus the x is equal to 180. Okay, and now the reason why I'm doing this is because it's gonna come up in your SAT, 100%. So you have to learn how to do this. Now, does anyone know what happens when you put two x's together?
X squared.
Not quite, that's when you're multiplying it, but when you're adding them, it's like saying I've got,
Square root of 2x.
it's 2x. Okay, so what happens is it becomes like this, 38 plus these two become what essentially 2x's, because there's 2x's. Only when it comes to adding, yeah, equals 180. Now, what do I do from here?
180 which is 38 divided by
Let's take away the 38. So this is a plus 38, it becomes minus 38. So, Joy, you're right, you are in a sense switching it.
So stop.
Yeah,
I mean, like 2x equals the whole, or is it like half?
I'll show you in a second. You're very close though. Solve this for me though, Donovan. What's 180 take away 38?
142.
Good. Okay, so you get 142.
By 2.
Divide that by
71.
Good. So where do you get the divide by 2? Well, here it's times by 2. What's opposite of times?
Multiply.
Divide. So here it becomes divide by 2.
Why does 2x equal 138 minus 180?
Because algebraically you've got to do it like that. It's 2x because how many x's do you have here? There's 2. 1x, 2x. And then here, when you write it algebraically, put all the numbers and letters together. Here there's 2 x's, so I'm going to put them together. So it becomes 2x.
So it's 71 degrees.
71 degrees is the answer for one of those x's. All right, and then you'd write here as an answer, because it's an isosceles triangle, let's just write isosceles triangle.
What if you just write triangle?
It should be okay, but I want to be as accurate as possible for you guys. So I'm just going to write isosceles triangle for you. Does that one make sense, or is that a bit tricky?
No, it makes sense.
Bit tricky? Do you want to try B? We'll do this one.
I'd rather be the other one.
Yeah.
Is the last one 180? So
Well, triangles always equal 180, yes?
180 divided by 3 because it's a possible equilateral, and then you just copy
Yeah.
it over to the x.
Yep. So let's figure out what that x is though, yeah? We don't know what it is, but we know, at the very least, look at the parallel lines. Does it have an alternate somewhere? Where is it? On the top. So this guy has to be x2, or x as well. Now, because it's an equilateral, remember equilateral, all three sides have to be the same. So that means all of these are the same angle. They're all x's. So if I did it like this, x plus x plus x, it's a triangle. What should they all equal?
3x.
180. So Tommy's right. It becomes 3x equals 180. So what do I do now? Divide it. Divided by 3. You guys are good at this. Very nice. There you go. X is 60. And then you'd write equilateral triangle. Equilateral. Very basic, but kids don't get it. But you're good. You guys are good. Good job.
Just divided by 3.
You could have done it that way too. But in year 11 and year 12, they want you to show algebra. Yeah, that's why. That's why I'm showing you this.
Can you just write it like that?
In year 10, or get ready. I'm getting you guys ready, man. So it's got to be algebra, properly algebra.
Listen, do I have you next year?
Maybe. I don't know. We'll see. All right, let's do this one. This one's not that bad. And then we'll do the last one, and then that'll be it, okay? So for these questions, all you have to do is you've got to figure out, firstly, what kind of shape are you working in? Is it like a 3-sided, 4-sided, 5-sided, 6-sided? Because you need to figure out what's the total angle first. Always figure that out. We know triangles always equal 180. If you want, you can actually put it here. Okay, equilateral. Put in there you want.
All triangles equal 180.
All triangles equal 180, even if it's equilateral or not equilateral, doesn't matter. How about a square? What's the angle for a square? Anyone know? 360. Always 360. Rectangular prism?
Also 360.
540.
That's a pentagon.
Oh, sorry, pentagon, yeah. Regular hexagon is 720.
Ah,
Do we see what's happening here?
heptagon would be
It's always going up by 180. Yes.
So it says here that the interior angle is 180 times n take away 2, but then it says divided by n at the bottom.
Yes. I'll tell you why. Then I'm just putting here, so sometimes, I guess you can kind of skip this, because now I'm writing out the angles for you. So you can always just look back here. What's the number of degrees for each of those shapes, depending on what shape I'm working with. All right, because Todio is not always the greatest with math. What's the next one? Next one is,
900.
I think it's 900. 720 plus 180.
900.
Should be 900, yeah.
You just added 180 there.
Yeah, each one it goes up by 180. And this one becomes 1080. And what's the next one? 1080.
You know, it goes up by 180.
Well, if you use this formula, I'll show you why. Okay, but the next
I
one,
get it now, I get it.
next one is going to be 1080 plus 180, 1260. And what's the last one?
2000.
1140. 1440. Okay, now I'll show you why this is the case. Yeah. All right. If you use this formula and you want to figure out the total angle, let's say you have a square or a four-sided shape. So let's use a square. So to use that formula, you don't have to use it, but what happens is it goes like this: 180 times n, which is the number of sides, 4 minus 2, and then divide the whole thing by the number of sides, which is 4. So if you put it in your calculator, that'll be more than that. 180 times,
Wait, which one are you doing?
I'm just trying a four-sided shape, divided by 4. The answer will be 360. Oh, 90. Oh,
How did you get
I
higher?
was confused about.
that doesn't make sense. I think
90.
this one we don't need then. That's why. That's right. I don't think you need the X, the end and the bottom.
Maybe that tells you the average angle of every.
We'll get rid of it for
If I
now.
go, wait, hang on, I want to try.
That's fine. I'll leave it for now.
Wait, can I try 80 and 40? How many sides is 5?
Oh, I know why. Okay, this is when you have equal sides. That's why. But generally speaking, you're going to work with questions that don't have equal sides. Okay, so it's fine. You're never really going to get these simple ones. All right. Let's just do these examples, and then we'll finish up very soon.
Gives you the angle of every corner.
Yes, it does. But that's if it's an equal side.
Yes.
Okay, let's look at this shape. This is a four-sided shape. Okay, if you're working with a four-sided shape, what's the total angle, guys? 360. Now you can use that formula where you did 180 times n minus 2 divided by 2. But we won't use that for now. Let's just go, we know it's 360. So therefore, 130 plus, what are these angles here?
90.
90
So 180.
plus another 90
180.
plus x equals 360. All right, solving that, put these together. What's that? 310. 90 and 58. Just wait, don't go ahead. So it becomes 310.
Mr. What shape is that?
Wait,
It's a four-sided shape.
Also, it's always going to be 360.
It's always going to be 3. That's why I put that up here for you. So you can just refer to this and see how many sides does the shape have. Well, it's that. There's the degrees for it. Okay. Well, there from there minus 310. Therefore, x is 50 degrees. It says here you don't have to provide a no reason needed.
The next one is 125.
This is 90.
and then what's your reasoning for it?
You don't have to provide reasons for these ones.
Wait, you don't have to put reasons.
For these ones, I believe only with triangles you have to, and those weird shapes. But these ones are okay. How about the next one? So this is a 5-sided shape.
549.
So just look which side has 5 sides. There you go, 540. All right, so let's use the 540. So it's going to be x plus 95 plus 120. What's this angle here, guys? 90, good.
X is 50.
Plus 110 equals 540. Put all the numbers together, yeah?
125.
Use your calculator if you get confused. So that's 95 plus 120 plus 90 plus 110 equals 415. So you're left with x plus 415 equals 540. Say that again, Joy. So what's the next step?
540 take away 1.
Good.
That becomes X.
125. Beautiful. Easy.
Simple as that, buddy.
Okay. Alright. I'll leave it up. Last one, and then that'll be it. Okay. This is the one where everybody gets confused. The very last one.
Manipulate all your grades.
Simple as
Go on to the
that.
next page.
Next page.
Listening for me.
Last one.
What do you mean last one?
I'll just do one example for the last one, and that's it.
Do I have to write
do whatever.
quadrilateral?
No, you don't have to. This one doesn't necessarily ask for it. But if it does, then I would put it in. Quadrilateral, equilateral, or whatever it is. Okay, let's look at the last one here. Okay, it's all right. This actually isn't that bad. Okay, it's not as bad as you think it is. It's not as bad as you think it is. No, I'll do this one.
A is just double of
All right, perfect.
A is just double of B.
Okay, so for this question, guys, let me show you how to do it. I don't know if you've ever done it in year 9 and year 10. Oh, year 9? But that's okay. So remember, with this shape, let's look at the first one. Anyone tell me what is interesting with this shape? What do we see?
Isosceles.
You see an isosceles, yep. You see two lines, two parallel lines. It's going to be important. Parallel lines are going to be important here. And you're looking for angle A. A bit confusing, but you're looking for that angle there. So how do we find that? What you need to do with these questions is you need to add a parallel line somewhere. Anyone want to tell me where would you add a line?
The co-interior between C and D.
Between C and D, so you're saying in here somewhere?
Well, I'd say
Maybe. Yes, you would make it a co-interior somehow? Yes, Charlotte?
Through A.
You'd put it through angle A. Good, I like that.
And Mr. A and B and D and E is the same, yeah?
Oh, not necessarily.
Just put the little arrow.
Oh, the line? Yes. But what you do is you have to add a parallel line between the A. Well, where C is or where A is. We're looking at angle A. So the way I like to say it is put a line through what the angle you're looking for. So you're looking for A, let's put a line through there. It has to be parallel.
Why do you do that?
I'll show you. It's parallel now, yeah? Keep that in mind. Now here's the thing. Whenever you have parallel lines, look for alternates and opposite angles and co-interiors, yeah? Tommy, this is 35 degrees. Can you find the co-interior brother of that angle?
What's the co-interior again?
So it's the same angle but on the opposite side.
Yeah, it's there.
Where?
On the end.
Where? Tell me where. So where is this 35 also 35? Can you see?
Oh, in between the thing.
Right here?
Line.
Here, where I circled it? Good. That's also 35. Very nice.
That's actually small.
That's 35 too. Okay. Now, I'm going to use a liner's co-interior trick. Remember, any angle within a co-interior always equals 180. So if that's already 120, what's this guy here? 60. Good. Easy.
But why is it always 180?
Because it's like two. Think about this. This angle and that angle. What do they equal? It always equals 90. Yeah. When you add them together, it's 180.
Oh, 180 plus 120 plus 60.
No, not quite. So we're just looking for angle A.
at the bottom, so that the one on top is gonna equal the same.
Just wait. We're looking for angle A.
Oh,
Co-interior.
So angle A should be 60 plus 35.
It's actually
95 degrees.
it's fun when you get it.
It actually is fun when you get it. Let's do one more, and then that'll be it. And it's just, okay, last one. Promise.
What's a 95?
Fine. For the,
The right zigzag.
no, you just leave it like that. There's no, I don't think there's reasoning here. So you don't say zigzag as reasoning, okay? They won't accept that. All right, you've got two parallel lines. Remember, you're looking for angle A, so where do we put the line?
Through the middle.
Through the middle, all right? Right there.
Voice crack.
Easy, all right? And looking for angle A, all right? Look for alternate angles here. I can see a 62. Where's the 62's brother?
Halfway there.
Halfway. So this guy has to be 62 as well. Okay, what about 51? I see 51 here.
51's gonna be on the left side.
Well, on the left side of the A, yes, over here. So what do we do next? Just add them all up. So that means angle A is equal to 51 plus 62, which equals 103 degrees. There you go. That's all you're doing for these questions. They're not actually that hard.
Yeah.
Sorry. I was testing it. Cool. I'll have some, yes, cool. All right, that's it for that, guys. I'm gonna stop recording. I'm hoping that recorded. Tommy, how do you stop recording again?
It's like
Control Shift 10?
Control Shift, Windows Shift and Q.
I'll have to edit it later. That's all right.
It comes up when you start recording.
Yeah, it does. All right, young'uns. So that's essentially it for that. I want you to think now with the questions.